Okay, so let's work out a few examples for our simplifying our squares, okay? And so here, all of these are going to be called perfect squares. We do that because whenever we take the square root of it, it ends up being a whole nice pretty number, okay? So like here, the square root of 81, what number times itself equals 81? Well, if you're uncertain, this list can help you. Look down there and see if you can find the square root of 81. Well, it's right there. The square root of 81 is 9. Okay, is 9. All right, going on to the square root of 484. That's not on your list, right? That's huge. The largest that goes to is the square root of 225, which is 15. So this number is much bigger than 225. So sometimes you got to kind of guess and check, okay? So 484, let's at least give ourselves an educated guess. That's a pretty big number. I could say for sure that I know off the top of my head that 20 times 20 is 400, okay? 20 times 20 is 400. 2 times 2 is 4. Add a couple zeros, you got 400, okay? That's bigger than 400 though. Okay, so that's bigger. So maybe grab your calculator. And so I know it's bigger than 20 times 20. Maybe 21 times 21. What's that gonna give me? 21 times 21. That's 441. Ooh, still not enough. Let's do 22 times 22. What's that gonna give me? 484. So the square root of 484 is 22. Why do you ask? Well, because 22 times 22 equals 484. All right, so number 3, I'm gonna let you guys do this one, okay? Now, in math, we need to make sure that we know how to read things, right? And so I have this 18 hanging outside of this radical. What does that mean? Well, when you have two values squished up next to each other, just like if you had 18 times, let's just say 4, okay? This 18 is right up next against this parentheses, and then there's a 4. So I understand that these are two different values. I understand that it's not 184, right? There's an operation between here, and that operation is multiplication. That's the same thing here. I have 18 times this radical, okay? So what do you do first? Do you multiply first? Do you say 18 times 4 first? Or do you solve the radical? Well, remember, these radicals are exponents, guys. Remember, they're just exponents, so all the rules of exponents apply. Whenever we do order of operation, please excuse E for exponent, okay? That happened before multiplication. So the first thing you want to take care of is that square root of 4. So the 18 still hang out. The square root of 4, what times what equals 4? The square root of 4 is 2. Now you can't just write it like that because now it looks like 182. You need to still make sure your multiplying stays intact. So that can happen sometimes whenever you're simplifying an expression. When multiplication was understood before, if you just solve the square root, if you simplify that square root and just write 2, that multiplication won't look like it's there anymore. Okay, now 18 times 2 is 36. Okay, so that's your answer. Okay, 3 times the square root of 256. So looking back on our sheet, we have 225, that's as high as it goes up to. So what is the square root of 256? Well, just take your calculator. I know it's bigger than 15 because the square root of 225 is 15. Maybe it's 16. 16 times 16? Yep. 16 times 16 is 256. So that means the square root of 256 is 16 times 3. So now to continue to solve this problem, we have to multiply 3 times 16. Well, 3 times 10 is 30. 3 times 6 is 18, so 48. Okay. I'm gonna leave number 6 for you guys to do. All right, so here we have a fraction inside of my radical, okay? So if we recall when I was explaining that these are just exponents, how would we have done something like this with an exponent? Okay, remember that the exponent goes to each piece inside of your term. So this is the same thing as saying the square root of 1 divided by the square root of 16. So you can always divide the radical, okay, into each factor of your term. So the square root of 1, well, 1 times 1 is 1. So the square root of 1 is just 1. That one's really easy. What's the square root of 16? Well, 4 times 4 is 16. So the square root of 16 is 4. All right. Now you notice whenever I solve that radical, whenever I simplify it, the square root of 16, I say it's 4. You notice I don't have that radical anymore. Okay, that radical goes away. That's your operation that goes away. So I know sometimes students will continue to write that radical even through the answer, but you've already solved it, so you don't need to do that. Okay. All right, I'm going to leave number 8 and number 9 for you to do. Okay, so the next step, we are going to be simplifying what we call non-perfect squares, okay? And so I want to show you a technique that maybe you've heard of before. It's going to help us simplify some of these radicals, okay? So you can have the number, let's just say 24, okay? There's a process called factoring, okay? And that process involves taking a number, such as 24, okay, and rewriting it as a multiplication problem. So instead of saying 24, maybe I could say 6 times 4, okay? So you're thinking, well, why would I do that? It kind of seems like I'm working backwards. 24 seems a lot more simpler than 6 times 4, okay? And yes, that's true, but now that we're getting into a little more advanced math, okay, sometimes we have to take a step backwards to be able to move forwards, okay? So this process is called factoring, and we're gonna get into a whole lot of factoring next section, okay? But right now, all I want you to know is that this idea of factoring is rewriting your number as a multiplication problem, okay? And so what we're gonna do is we're gonna look and we're gonna factor in a very specific way, okay? What we want to try and do is factor out, okay? This is what I'm saying. Factor out perfect squares, okay? So what does that mean? So I have the number 24. I wanna look at my perfect square list, okay? I have 1, 4, 9, 16, 25, and so on, going down and down. And I want to say to myself, can I rewrite 24 as a multiplication of a perfect square? Well, 4 is a perfect square, right? So I successfully wrote 24. I factored it so that one of my factors is a perfect square. Okay, one of my factors is a perfect square. So how is that gonna help me? Okay, and so maybe I'll write it just like, it doesn't really matter which order you write it in. Maybe I'll write it like this so that it looks really nice and easy. Okay. So what's that gonna do for me? Well, let's look under here. So the idea of whenever you are simplifying a radical, you want to get rid of the radical ideally, like here, right? You want to just get rid of it because it's not as clear of communicating that value. But sometimes you're not going to be able to get around it, okay? But if you can make the number inside of the radical as small as possible, that would be considered a simpler way of writing that value, okay? So I want to make whatever's inside of my radical as simple as possible. So what I ask myself is there any number, any perfect square down my list, 1, 4, 9, 16, 25, 36, go all the way down. Is there any way I can write 24 as a multiplication problem? And yeah, I can write it as 4 times 6, right? Okay, so 24 is the same as 4 times 6. What does that allow me to do? Well, remember that my radical is just an exponent. So whenever you have two different factors in your exponent, that exponent gets to go to each piece. So I can rewrite this as the square root of 4 times the square root of 6. You notice I can just butt those up next to each other and not write a time symbol anymore, because in mathematics, if you have two values right next to each other, it's understood that multiplication is happening. Okay. What is this going to do to help me? Well, I can solve a little bit. I can simplify the square root of 4, right? What times what equals 4? 2 times 2 equals 4. So instead of writing the square root of 4, I get to write 2. Now, granted, I still don't know what the square root of 6 is. So this answer, this value is now simplified, okay? You take the square root of 24 and you simplify it by writing it as 2 times the square root of 6, all right? Why is that more simplified, do we say? Well, because the number underneath the radical is smaller, okay? So that's what we want, ideally. We want the number underneath the radical to be as small as possible.